the enigmatic legacy of Jabir ibn Hayyan. Greetings, esteemed scholars and enthusiasts of the history of science. Today, we delve into the intricate and enigmatic figure of Abu Musa Jabir ibn Hayyan, a name that resonates profoundly within the realms of alchemy and early chemistry. Flourishing ostensibly in the 8th century, Jabir ibn Hayyan is often hailed as the father of chemistry, yet his very existence remains a subject of scholarly debate. Attributed with the authorship of the extensive Jabirian corpus, comprising over 600 works with diverse topics ranging from alchemy, magic, and Shiite religious philosophy to cosmology, astrology, and grammar, Jabir's influence is indisputable. However, the complexities surrounding his historical footprint and the profound depth of his contributions invite us to explore beyond the surface. Join us as we examine the profound legacy of Jabir ibn Hayyan, dissecting his contributions with technical precision and delving into the debates that shroud his historical and intellectual identity. To understand the depth of Jabir ibn Hayyan's contributions, one must navigate the sparse and often ambiguous biographical accounts of his life. Purportedly born in Tus, a city in the Khorasan region of northeastern Iran, his life's timeline is typically placed in the early to mid-8th century CE. His affiliations are suggested by various nisbas. Al-Azdi implies connection with the Azd tribe, a prominent Arabian tribe, while Al-Tusi associates him with his birthplace. The debates surrounding his ethnicity hinge on whether he was an Arab member of the Azd tribe or a Mawla, a non-Arab Muslim client, potentially of Persian origin. This nuance is critical, considering the cultural and intellectual exchanges between Arab and Persian scholars during the Islamic Golden Age. Jabir is traditionally portrayed as a disciple of Imam Jafar al-Sadiq d. 765 CE, the 6th Imam in Shiite Islam, suggesting deep roots in early Islamic theological and philosophical thought. Additionally, he is linked to the Barmakid family, particularly Jafar ibn Yahya al-Barmaki, a notable vizier under Caliph Harun al-Rashid. These affiliations, however, are primarily derived from later compilations and the Jabirian corpus itself, lacking contemporaneous corroboration. Such ambiguities fuel the ongoing scholarly discourse regarding his historicity and the authorship of the works attributed to him. The Jabirian corpus stands as one of the most monumental literary collections of the early medieval period, attributed to a single author. Encompassing approximately 600 works known by name, with around 215 extant today, the corpus presents an extensive exploration of alchemy and chemistry, interwoven with philosophy, cosmology, mathematics, medicine, and more. The diversity and depth of these writings reflect a comprehensive scholarly pursuit, aiming to systematize knowledge across disciplines and to bridge empirical investigation with metaphysical inquiry. The corpus is systematically organized into several key collections, each with distinct thematic and methodological characteristics. The Great Book of Mercy, Kitab al-Rahma al-Kabir. Regarded as one of the earliest and most foundational texts, this work delves into the core principles of alchemy. It outlines practical techniques for substance transformation and discusses philosophical underpinnings. The significance of this text is highlighted by references from later scholars, including a now-lost commentary by Abu Bakr al-Razi. Its Latin translation, Liber Misericordiae, indicates its influence on European alchemical traditions. The 112 books, Al-Kutub al-Mi'a wal-Ithna Ashar. This collection is characterized by concise treatises addressing diverse practical aspects of alchemy. It emphasizes the interpretation of symbolic and cryptic references from ancient sages. Notably, it pioneers the incorporation of organic substances, vegetable and animal matter, in alchemical processes, marking a significant expansion from traditional mineral-based practices. The 70 books, Al-Kutub al-Sabrun. This series presents a systematic and structured exposition of alchemical knowledge. Divided into 7 parts, each containing 10 treatises, it covers topics such as the preparation of elixirs from various substances, theoretical examinations of the 4 elements, earth, water, air, fire, and practical applications. The Latin translation, Liber de Septuaginta, attests to its enduring relevance. The Books of the Balances, Kutub al-Mawazin. Comprising 144 treatises, this collection is devoted to the science of the balance, Ilm al-Mizan. it seeks to quantify all phenomena, asserting that understanding the precise measures and proportions of natures within substances enables manipulation and transmutation. The works extend beyond chemistry into cosmology, music theory, medicine, and logic, reflecting an ambition to establish a universal scientific language. The 500 books, Al-Kutub al-Kamsumiyya. This extensive collection mainly engages with religious philosophy, including eschatology and imamology. It integrates moral and ethical reflections with allegorical interpretations of alchemical concepts, illustrating the interconnectedness of spiritual and empirical pursuits in Jabirian thought. The meticulous organization and comprehensive scope of the Jabirian corpus underscore its ambition to encompass and systematize the entirety of contemporary knowledge, positioning it as a cornerstone in the intellectual heritage of the Islamic world. A hallmark of Jabir's contribution is the systematic classification of chemical substances, arguably the earliest of its kind. He categorized substances into three primary classes: spirits, awa, highly volatile substances characterized by their ability to vaporize upon heating without decomposition. This class included mercury, sulfur, and notably sal ammoniac, nushadir. The inclusion of sal ammoniac was innovative, stemming from its derivation from organic sources and its role in sublimation processes. Metals, ma'din. This category encompassed 7 noble and base metals: gold, silver, copper, iron, tin, and carcini, an enigmatic Chinese metal, each defined by specific physical properties and internal natures. Stones, ajar, non-metallic minerals and compounds that played significant roles in alchemical operations, including salts, ores, and various crystalline substances. This classification facilitated a structured approach to experimentation and theoretical exploration, allowing for systematic investigations into the properties and transformations of materials. Jabir's work is particularly notable for pioneering the synthesis of inorganic compounds from organic materials. He provided detailed procedures for the production of sal ammoniac, ammonium chloride, through the dry distillation of organic substances such as blood, hair, and plant matter. This process involved thermal decomposition, where organic compounds were heated in closed vessels, releasing vapors that condensed into crystalline salts. The significance of this innovation lies in its deviation from the traditional reliance on mineral sources. By demonstrating that inorganic compounds could be derived from organic origins, Jabir expanded the scope of alchemical research and influenced subsequent developments in chemical synthesis. This approach also implied an early understanding of the conservation of mass and the transformation of matter, prefiguring concepts central to modern chemistry. Central to Jabir's theoretical framework is the science of the balance, ilm al-mizan, a sophisticated system aimed at quantifying the qualitative properties of substances. Drawing from Aristotelian and Neoplatonic philosophies, Jabir posited that all matter comprises a fundamental substrate endowed with 4 elemental natures: hot, cold, moist, and dry. In Jabirian methodology, these natures are assigned numerical values, enabling the quantitative analysis of substances. By calculating the precise balance of these natures within a material, one could predict and manipulate its properties. For instance, metals were thought to differ based on the internal balance of these natures, a concept that extended to intentional transmutation through controlled adjustments. This theoretical model facilitated an empirical approach to alchemy, blending mathematics with chemical experimentation. It represents an early attempt at stoichiometry, anticipating the quantitative relationships between reactants and products in chemical reactions. The science of the balance underscores Jabir's ambition to unify natural philosophy with practical alchemy, striving for a comprehensive understanding of the material world. Jabir's contributions are not confined to theoretical constructs. He also advanced experimental techniques and laboratory practices. He emphasized the importance of systematic experimentation, advocating for detailed documentation and repeatability of results. His writings provide elaborate descriptions of apparatus, such as alembics, crucibles, retorts, and furnaces, many of which he improved or standardized. Jabir outlined processes including distillation, sublimation, calcination, evaporation, and crystallization with meticulous attention to procedural details. He highlighted the importance of purification, removing impurities to isolate the desired essence of a substance. This focus on purification reflects an underlying philosophical quest for perfection, both materially and spiritually. By integrating empirical methods with rigorous theoretical analysis, Jabir established a methodological foundation that influenced subsequent generations of alchemists and chemists. Jabir ibn Hayyan's intellectual pursuits transcended alchemy, encompassing profound philosophical explorations rooted in Shiite theology and Neoplatonic thought. His works reflect an integration of metaphysics with empirical science, asserting that the material and spiritual worlds are interconnected through universal principles. A key aspect of his philosophy is the concept of balance, not only in chemical substances but extending to ethics, cosmology, and spirituality. He espoused the idea that understanding the underlying properties and measures of all things leads to a harmonious existence, aligning with the Shiite emphasis on esoteric knowledge and inner truths. Furthermore, Jabir's writings delve into imamology, discussing the roles and attributes of the imams as bearers of divine wisdom. He often employed allegorical interpretations, using alchemical processes as metaphors for spiritual purification and transformation. This synthesis of disciplines underscores the holistic nature of knowledge in his worldview, where science serves as a means to comprehend and engage with the divine order. At the core of Jabirian alchemy lies the sulfur-mercury theory of metals, a paradigmatic model inherited and refined from earlier traditions. This theory postulates that all metals are formed from two primary principles: sulfur, representing combustibility and fusibility, associated with the qualities of dryness and heat; mercury, mercurius, symbolizing metallic properties such as luster and malleability, linked to moisture and coldness. Jabir expanded upon this model by introducing the concept of pure and impure sulfur and mercury, influencing the qualities of the resultant metal. The formation of metals within the Earth's crust was thought to result from the varying proportions and purities of these two substances under the influence of cosmic forces. Gold was considered the epitome of perfection, a result of the optimal balance and purity of sulfur and mercury. Other metals were seen as deviations from this ideal, possessing defects that could, in theory, be corrected through alchemical processes. This conception provided a coherent framework for the practice of metal transmutation, guiding experimental efforts in pursuit of the philosopher's stone, elixir. The endurance of the sulfur-mercury theory in alchemical thought for nearly a millennium attests to its profound impact on the study of metallurgy and chemistry prior to the modern atomic theory. The historicity of Jabir ibn Hayyan is a subject of enduring scholarly debate. While the vast corpus bearing his name signifies a towering intellectual legacy, contemporaneous records of his life are conspicuously absent. Early biographical sources, including comprehensive Shiite works cataloguing associates of Imam Jafar al-Sadiq, make no mention of Jabir. Philosophers such as Abu Sulayman al-Sijistani and Abu Hayyan al-Tawhidi expressed doubts about Jabir's authorship, suggesting that the works were pseudonymous, a common practice wherein later scholars attributed their writings to esteemed predecessors to gain authority. The absence of Jabir in earlier historical records and biographical dictionaries further fuels the skepticism regarding his existence as a historical individual. Modern textual analysis provides critical insights into the dating of the Jabirian corpus. Linguistic and terminological examinations reveal that the philosophical and scientific vocabulary employed in the texts aligns with developments occurring in the 9th century CE. Additionally, the corpus references Greek philosophical works that were translated into Arabic toward the end of the 9th century. The Shiite theological concepts articulated within the corpus correspond to doctrinal developments of the late 9th and early 10th centuries, including advanced imamological notions absent from earlier periods. These findings suggest that the corpus was composed between 850 and 950 CE, considerably later than Jabir's purported lifetime in the 8th century. Consequently, many scholars posit that the Jabirian corpus is the product of a collective of anonymous alchemists and scholars, possibly associated with the Brethren of Purity, Ikhwan al-Safar, or other intellectual circles in Kufa or Baghdad. The attribution to Jabir ibn Hayyan may have served to legitimize and preserve the works within the respected framework of early Islamic scholarship. Regardless of the uncertainties surrounding his personhood, the influence of Jabir ibn Hayyan, real or symbolic, is profoundly imprinted on the trajectory of alchemy and chemistry. The systematic approaches, experimental techniques, and theoretical frameworks presented in the Jabirian corpus significantly advanced the scientific discourse of the Islamic Golden Age. The transmission of Jabir's works to Europe began in the 12th and 13th centuries, as Latin translations made under the name Geber reached scholars in Italy, Spain, and beyond. Texts such as the Summa Perfectionis Magisterii synthesized Jabirian principles and became foundational references for European alchemists. The figure of Geber attained legendary status, often conflated with the historical Jabir, and influenced prominent figures such as Roger Bacon and Paracelsus. Moreover, the corpus's emphasis on empirical observation, quantification, and systematic experimentation foreshadowed key aspects of the modern scientific method. Jabir's integration of science with philosophy and spirituality exemplifies the interdisciplinary scholarship that characterized Islamic intellectual traditions. His legacy persists not only in the historical foundations of chemistry, but also in the enduring quest to understand the natural world through a synthesis of rational inquiry and philosophical contemplation. In exploring the enigmatic legacy of Jabir ibn Hayyan, we traverse a rich tapestry of scientific innovation, philosophical depth, and historical intrigue. Whether as an individual pioneer or a symbolic representation of a collective intellectual movement, the contributions attributed to Jabir have indelibly shaped the development of alchemy and chemistry. His works embody a pivotal era where empirical investigation and metaphysical exploration coalesced, reflecting a profound commitment to uncovering the secrets of the universe. As we continue to build upon the foundations laid in centuries past, the spirit of inquiry exemplified by Jabir remains a guiding beacon in our ongoing pursuit of knowledge.